Hi, everyone. Rybone here, back with another episode of the Weekly Purple Team. This week, we're taking a look at Charon. This is a project that aims to obfuscate and bypass EDR with the feeding in of shellcode. And boy, does it work. It's only a few days old, as you can see as of this recording, 3 days old. But it is using some pretty advanced techniques to get by EDR, and it's getting by a lot of them. We'll demonstrate it getting by Defender. It uses Tartarus Gate, which is an evolution of Halo's Gate, L-Hall, which is indirect syscalls, KeyGuard, and monolithic compilation. So what does this mean we can do? We can get things by EDR. Let's try something obvious. How about we try Cobalt Strike, right? One of the most well-fingerprinted tools out there. We're going to get Cobalt Strike by Defender with Charon. All right, so we'll start over here on our Kali box. We have the newest version of Cobalt Strike. As you can see, it's even the new GUI. This is the very newest version of Cobalt Strike. And what I've done here is I've generated a Windows stageless payload, and I've done it in RAW. Now, I've done some other things to make this a bit harder to detect. I'm not using, default things, and I'm using malleable C2 framework to make this look like AWS. So it's not your typical just off-the-shelf Cobalt Strike. It was already somewhat invisible to EDR, but that does not mean that Charon isn't doing the heavy lifting here, right? I'm just giving it shellcode. It's doing the heavy lifting. So we're going to go ahead and if we do generate here, we could select a listener. And you can do generate, and basically it'll generate a piece of shellcode. I've already done this, and I've moved this over to my Windows 10 host, which is a Windows 10 host that I control. I've compiled Charon here, and I'm using the native command line for VS Code. You need to use the native command line for VS Code. You can't just run this from the command line. Right? It's using some pieces to do this compilation. So this is actually from Visual Studio. Right? So you can get the Visual Studio basically open source edition or core edition and do the same thing. But what we're going to do, I'm going to take my payload here. This is my shellcode from Cobalt Strike. I'm going to run through Charon, and then we're going to generate an executable from that. So I'm going to go ahead and do that. Now, this takes a long time, right? Because it's doing quite a bit of work to embed this shellcode into the executable, and then we'll get an executable out of it when it's done. I'll go ahead and start it here so you can see what it looks like. You can see it's reading shellcode payload 64. It does a new secret and int every single time you run an application through this. So if you ran that same raw shellcode through this, every executable is going to be different. So it's pretty cool. I'm going to go ahead and pause the video here because this takes quite a while. And then once we're done, we'll come back. So be right back. All right, and we're back. As you can see, our Charon artifact builder has completed, and it will output Charon artifact.exe. It always calls it that. Of course, you can edit the code to make it change that, or you can just rename it when the executable is done. At this point, I'm just going to go ahead and rename this. We'll call it CBS, and that just stands for Cobalt Strike. And we'll give it a payload. So we'll go 7-zip, and we'll go add to archive. And we'll give it a password, just like that. This is just to get it by smart screen for download. And now we have CBS. So at this point, we can use updog, and we can upload this to our Kali box or wherever you want just to get it onto the host. So we'll choose a file here. We'll go to our desktop, choose CBS, open, and then we'll upload. Okay. So we now have cbs.zip right there. So we're going to jump over to our Windows 11 host 1 now. And as you'll see, Defender fully on. The only thing that is not on is, as always, I do not have automatic sample submission on. Don't want them eating my beacons. And in this case, it really is a beacon. But everything else is on. fully connected. I haven't done anything to this system. So what we'll do now, we'll go download this. Go and close off these previous versions of 7-zip I have here and Timeline Explorer, just so it's out of the way. And we will go download our file that we just created. So we'll get cbs.zip right here. Now, Chrome is telling you now every single file that's a zip file is dangerous, which is funny to me. But there it goes. So we have our download. Now we have cbs.zip in our downloads folder. We'll unzip this. So right here, we can see CBS. Normally right here, Defender would eat it if it thought it was bad, right? So we're extracting it right here to downloads. We're going to give it the password. Nothing. What's even crazier? I'm just going to straight double click this. So I just straight double clicked that executable and then ran this. Now, of course, if you were going to do this in a real engagement, you'd want to hide all this, or you'd want to put it to where the window didn't have to stay up. But you could certainly do that, right? It's not that hard to edit the code to make it do that. This is just a proof of concept. We'll come back over here to our Kali box. And we should have a beacon checked in, and we do. So there you go. That's Cobalt Strike by Modern Defender. Now, this gets by a lot more than just Defender. I'll let you guys do your own testing. But so far, I've yet to find anything that's really catching this. Of course, if you find something that's catching it, let me know in the comments. I haven't tested every EDR that's out there. Now, I've tested some of the big boys, and it's getting by. I mean, like I said, this is a 3-day-old project. Okay, so we've got a beacon. At this point, for the blue team, detection is practically impossible, right? It's a random executable. The only thing you can do here is prevention, and that would be Windows Defender for application control or app blocker policies to ensure that people can't just run random executables that they download. But in most organizations, it is what it is. This is a working beacon. It's not a privileged beacon, but we can tell it's a working beacon. We'll just do something with it. Let's spawn. We'll spawn another session. So we'll choose our listener here, and we'll tell it to spawn. We should get another beacon here in just a second. It's got to do its count. I don't have it in sleep 0. So we got to wait the 30 seconds for it to do it, but you can see host called home, and now we have another beacon as WMI privacy. Now at this point, defenders can detect it, right? Once they start doing things with Cobalt Strike, you can start doing the detection because, well, this is just the beacon running as something. But I ran all sorts of auto detection things. I ran a whole bunch of different programs and nothing flagged on this first pass. So good on you, vari-sh. This is a crazy bypass, and it's getting by a lot of stuff. So very cool. All right, so we have our beacon. We did something here. So now we should be able to at least detect that. We jump over here to our Elastic SIM. We should be able to find this by doing simply event code 468 and process command line WMI priv se with stars. If I refresh this, we should be able to detect it. And what you'll see, if we come over here, we can see the user Bruce banner. We can see that WMI priv se.exe was launched. And if we go to where it was launched from, that's the telltale sign. Notice the parent process was cbs.exe. Well, why is something from downloads running running WMI priv se? You should have a rule looking for weird locations launching WMI priv se. Things like app data, downloads, user writable folders. Why are they calling WMI priv se? They shouldn't be. But just the launching of CBS or our CBS.executable, basically undetectable. There's nothing you can do. EDR is not going to trigger. You're not going to know it's a Cobalt Strike beacon. Now, if I come back over here and I have it do something else, right? So we'll do like a beacon interaction. So we'll do shell and we'll go, who am I? And we'll see, then we should see it running another program, right? So this is typically how you would catch a Cobalt Strike beacon is, okay, we can see we're hacking lab Bruce Banner. If we go back over here, we should be able to see it launch who am I now. So we'll jump back over to our Elastic and now we'll do who am I here. And you can see, here we go, right there. We have seen cmd.exe, and we should have a parent process. cmd.exe, we may have to find this. We can see Bruce Banner is running who am I. That's always a trigger. Let's see if the other one has it here. There it is, cbs.exe, running cmd.exe, see who am I. So the only way to catch this Cobalt Strike beacon is if they do something with it after the fact. The obfuscation has got it so just to where it's undetectable that you're not going to do anything with the original executable, the original beacon. But as defenders, we should not be worried about the original infection. I see so many people concentrating on the original infection so much that they don't look for the TTP after. You should always be looking for the TTP after. And I can tell you, the TTP after is going to be something weird, right? It's going to be a net command. It's going to be who am I? It's going to be, hey, AnyDesk was installed. Look for the weird. You're never going to be able to 100% detect first infection. It's just impossible. Right? There's too many vectors. But the second step or lateral movement, that's where you should be detecting the bad guy. All right. That's all I have for you this week. Hack the planet to defend better.
From the pillage, me.